Section 7-3, Graphing Ordered Pairs to Identify Linear Functions. Graph each set of ordered pairs to determine if it represents a linear function. If it does, find the rate of change. So what we're going to need to do is we're going to need to graph A part, and then we'll graph B part. We need to graph all of these ordered pairs that are in A on one graph and connect them. And if it's a linear function, which is a line, we will need to find the rate of change, which is also the slope. So let's graph these points. I'm going to graph all of these points onto one graph. All right, so my first point that I need to graph is the point 1, 5. Let's see if I can get all this on my screen. Let's graph the point 1, 5. All right, so here I am. I'm going to the right one, up 1, 2, 3, 4, 5. So there's my first point. There's the point 1, 5. I'm going to write these points over to the side. Here's the point 1, 5. Okay, next let's graph the point 2, 7. Okay, so to the right, 1, 2, up 1, 2, 3, 4, 5, 6, 7. There's the point 2, 7. Next, let's graph the point 3, 9. To the right, 1, 2, 3, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Then let's graph the point 4, 11. X, remember the first number's X, second number's Y. So you start at the origin, go to the right 4 on the X, 1, 2, 3, 4, and up positive 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then our last point is 5, 13. Okay, so let's graph that point to the right 5, 1, 2, 3, 4, 5, and up 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's connect these points. I see that these points do form a line. So therefore, this is a linear function. So yes, it is a linear function. Now, what we want to determine is the rate of change. Anytime you're asked to find the rate of change, you're going to be finding the change in Y over the change in X, or your vertical change over your horizontal change. So from this point, from the point 1, 5 to the point 2, 7, what did we have to rise and what do we have to run? So from this point, I will rise 1, 2. So I'll be rising 2, and what do I have to run to get to the next point? I have to run 1. Now rising is positive 2, running to the right is positive 1. So your rate of change would be 2 over 1. 2 over 1 is your rate of change. So for every point, you have to rise 2, 1, 2, run 1. Rise 2, run 1. Notice my slope for this entire line is constant. Every time I will rise 2 and run 1 to go to the next point. Okay? So your rate of change is 2 over 1, or we can just say your rate of change is 2 divided by 1, which gives you 2. So the rate of change for A is 2. Yes, this is a linear function because if I was to use my vertical line test and draw all the vertical lines that I could possibly draw, each vertical line would only touch my graph at one point. Therefore, this is a linear function. A part is a linear function. Now let's go to B part. We're going to be graphing B, all right? So I'm going to see if I can get all this on my screen. All right, I'm graphing the point 0, 0, 1, 1, 2, 4, and 3, 9, okay? So let's look at this graph. So 0, 0, that's my origin. All right. 1, 1 to the right 1 and up 1, okay? 2, 4 to the right 2 and up 1, 2, 3, 4. And then 3, 9 to the right 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, does this form a line? If you connect these, do I form a straight line? No, I do not. So this is not a line. You can't connect the points with a straight line, so the ordered pairs do not represent a linear function. So this is not a linear function. In order to be a linear function, it has to be a straight line. So this is not a linear function. The slope up this graph here would not be constant. It would not be constant. Your rise and your run are different in between these 2 points, or these two, or these two. Your slope is not constant. So when your slope is not constant, it is not a line, and therefore you do not have a linear function.